In today's note, we are going to look at writing exponential equations. So we're going to look at examples where we're given tables of values and we have to come up with the exponential equation. In the previous examples, when we looked at exponential growth and exponential decay, we had to come up with the equation based on kind of word scenarios or actual text. Here, what we're going to look at is given tables of values. And when we're dealing with tables of values, we can use a modified version of our exponential equation. That modified version is y equals a times b to the power of x. A is the initial value or the starting amount, or essentially the y value when x equals 0. So you can think of it as the y-intercept. B is the ratio of consecutive y values. So in the past two lessons at, again, exponential growth and decay, we did find the ratio when we were dealing with a table of values. And hopefully, if you go back and look, you can see that the ratio is the b value or the value that was in our brackets. So that's what we have to do to determine our equation. We have to find the a value or the starting amount and find the ratio from the from the table of values. So what we're going to do is just go through a couple examples where we're given a table of values and we have to determine our equation for it. And then we're going to use the equation to help us fill in the blanks in our table. So if I look at the first example, I'm looking for two things. One is my a value, or the starting amount, and the other is my b value in the ratio. Right off the bat, I can see my starting amount. It's the first value, x is 0, y is 3. So that's my starting amount, or that's my y-intercept, and that is what our a value is. So our a value is 3. To figure out the b value, I need to figure out the ratio. Again, the ratio is like first differences and second differences that we did with quadratics, except instead of subtracting, we're dividing. So 12 divided by 3, or bottom divided by the top, equals 4. 48 divided by 12 equals 4. 192 divided by 48 equals 4. And we see the pattern. The rest, or the other two, should be 4 as well. So in this case, our ratio is 4. So that is our b value. So if I go to my equation now, using the form in the box above, it's going to be y equals a, which is 3, or my starting amount, times my ratio, which is 4, to the power of x. So this is my equation, or exponential equation, for this table of values. I can use that now to fill in the missing boxes. So I could do 3 times 4 to the power of 4 and get my next answer. Or, understanding again the ratios, I could do 192 times 4 as well and get 768. Either way works. I could take 768, multiply it by 4, get 3072, or I could do 3 times 4 to the power of 5 and get the same answer. Because again, the ratio is telling what I multiply by to get to the next value. If we look at the next example, again, we want to figure out our equation, and we want to figure out by figuring out our ratio and our starting value. So again, we're looking for our a value and we're looking for our b value. The a value should be in this box here. However, I don't have that box. So in order to do that, or in order to find it, I need to first figure out what my ratio is. And by figuring out my ratio, I can then work backwards to figure out what that y value should be. So I'm going to go with my first two consecutive points, do 19.2 divided by 24. Again, you have to work your way down. You can't do the top divided by the bottom. It's the bottom divided by the top. And when I do that, I should get 0.8. If I do the next one, 15.36 divided by 19.2 equals 0.8. And if I continue that pattern, I get 0.8. And even though I can't figure out the next two, I can assume that it has to be 0.8 because in order for it to be exponential, all the ratios need to be the same. Now, to help me figure out the other values, I can use that ratio. And the way I use the ratio is, if I'm going down in the table, I'm multiplying the ratio, or I'm multiplying my value by the ratio to get the next value. So 24 multiplied by 0.8 gives me 19.2. 19.2 multiplied by the ratio gives me 15.36, and so on. If I want to go in the other direction, so if I want to go up my table, if I go up my table, I have to divide by the ratio. So if I'm going backwards, 19.2 divided by 0.8 gives me 24. And I can use that to fill in the next chart, or the next square, because I can do 24 divided by 0.8, which gives me 30. So that's how I can use the ratio to figure this out. Multiply by the ratio if we're going down, divide by the ratio if we're going up. If I look at my last column, I need to fill in this last chart, so I could do 12.288 multiplied by 0.8 and get 9.8304, or I could figure out my equation, because now I know that the a value is 30, and plug in x for 5, or 5 for x, and solve for y. So in my equation, it'd be y equals a, which is 30, times the ratio, or b, 0.8, all to the power of x. So this last box here, if I wanted to use the equation, would be y equals 30 times 0.8 to the power of 5, and I should get this answer as well. So again, if you're not given the a value or the initial value or the starting amount, you should have enough information to find the ratio, so then you have to work backwards in order to determine what that initial value is. But and you're using the ratio to work backwards. So we have two examples left. So I'm going to pause the video and give you a chance to try this on your own. Again, look for that a value and the ratio. If you can't find the a value, then hopefully you have consecutive points where you can find the ratio and then work backwards or forwards to figure out that initial value. So again, I recommend that you pause the video so that you can try this on your own. So coming back to our two examples, these are the solutions you should have. For C, we are able to figure out the initial value, or the a value, because it was given to us. We knew that when x equals 0, it was 20, so 20 was our a value. From there, we just had to determine what our ratio was, and we did that by dividing consecutive y values. So 22 divided by 20 gave us 1.1, 24.2 divided by 22 gave us 1.1, and then we can assume, because it's the same and it's exponential, that all the ratios have to be 1.1. From there, we should be able to fill in the rest of the table. Because we're going down, we could multiply each previous value by 1.1 to get the next value. We could double check that, going from the fourth value to the fifth one. If we multiplied 29.282 by 1.1, we should get 32.2102. Additionally, we could have came up with our equation, which was y equals 20 times 1.1 to the power of x, again using the ratio and the a value, and plugged in 3 and 4 to find those two missing boxes. For D, we didn't have the initial value to start with, so what we had to do first was determine our ratio. By determining our ratio between the consecutive points that we were given, we should have found that the ratio was 0.5. And by using that, we could fill out the rest of the table because, again, as we go down the table, we multiply each previous value by 0.5. Or you could see that as we go down, each next step is just half of the previous one. So we're dividing everything by 2. And then if we work our way going backwards or going up, we divide by a half or we multiply everything by 2. And we should get the initial value is 240. So that in our equation for this exponential relation is y equals 240 times 0.5 to the power of x. So again, just a short note, but it's just looking at another form of the exponential equation for exponential relationships, very similar to what we were looking at in the previous lessons on exponential growth and decay. However, now, as long as we're given a table of values and we're told it's exponential, we should be able to come up with an equation, again, by finding the starting value. Let me go back up to the original. By finding the starting value and by finding the ratio of consecutive y values.